came out is, of course, Bitcoin. Who here has heard of Bitcoin? Okay, lots of hands not up. Many people have not heard of Bitcoin. That's okay. So Ethereum is similar, is a blockchain in the same way that Bitcoin is a blockchain, except Bitcoin only supports a limited number of applications, right? You can hold Bitcoins, you can transfer Bitcoins, you can have multi-sig wallets, you can have a small number of other things, but that's the end of the functionality, right? It's a blockchain that's designed around one particular use case and optimized around doing that well. Now, Ethereum is a general purpose, right? So Ethereum has a built-in programming language. You can write programs. You can publish those programs onto the Ethereum chain, and these programs are called smart contracts. And by doing that, Ethereum as a blockchain can run applications that you create, right? And anyone can publish applications to the chain that run on the chain. So this programmability makes Ethereum general purpose, which makes it possible for people to use it for just all kinds of different applications, going far beyond just currency and tokens. Another way to think about Ethereum is it's open source software, but with a shared hard drive, right? So who here remembers the open source software movement for the last 10 years, 20 years? Who here has run Linux before? Cool, amazing. So open source software has been a really big theme in the software industry for basically about the last 40 years. And it's a reaction to proprietary commercial software where in the late 1970s and early 1980s, people started selling software packages where they just gave you a piece of code where the code was already compiled. And so you could not inspect it, you could not see what was going on, you could not modify it. And because they were using copyright law, you could not even legally give a piece of software that you have to your friends. And open source software was a movement to try to fight back against some of these things. And basically, to try to create a community around publishing software where the code is open, and when you download it, you can see how it works. If you want to change it, you can change it. You can change the code, you can modify it, and so you can actually understand and control the things that are actually running on your computer, right? So free software is also a very common early term for this, right? Free as in freedom. And it's, but the open source and free software movement has, I think, become still extremely important and extremely influential, but also a bit incomplete over the last 20 years. And the reason why it's become incomplete is that the tools and software that we all use for the last 20 years is software that talks over the internet, right? So 20 years ago, the most important software that was being created was things like word processing, Microsoft Word, Excel for spreadsheets, games, Adobe Photoshop, things like this. And these are things that live on your computer. The problem is that more recently, we have software that is inherently dependent on users talking to each other, right? Like social networks. You have Twitter, you have Facebook, Instagram. All of these involve my computer talking to your computer and going through some server. Now, it doesn't matter if the code for the server is open because there's a server. And you don't actually have any way to trust what code is the server actually running. Right? Whoever runs that server, they can control who can participate in the application, who is allowed to have an account, who cannot have an account. They can see all of your data. They can change how anything works. They use proprietary algorithms to decide what content gets shown more, what content gets shown less, that are completely opaque, that none of us can see. And this is kind of the new norm, right? And in some ways, it's even worse than the status quo 20 years ago, because 20 years ago, even if you had closed commercial software like Microsoft Word, it's running on your computer. And you would still know that it's just running on your computer, and it's not sending all of your information to Microsoft. Now, basically all important software does things over the internet, and so you do not even have that. Right, so what do blockchains do? Blockchains let us create open systems that do involve lots of people collaborating with each other, and lots of people talking to each other, participating, doing things that affect each other. Right? So when you have an account on Ethereum, it lives on this thing called a blockchain that you can think of as being like this shared hard drive. Right? It's a hard drive where anyone can upload things, anyone can download things, and it even lets you run programs. And so different people can upload their own programs and their own data, and you can make applications that then work off of that user's data. And so you can build applications that involve interactions between thousands or millions of users without there being this server in the middle that controls everything, that sees everything, and that can cheat, that can change the rules, and that can control who can and can't participate at any time. Right? So this is like another way of seeing what Ethereum is trying to do. A third way of seeing what Ethereum is trying to do is it's a platform that lets us create different kinds of social institutions with this property that we call hardness. So Josh Stark last year wrote this excellent post called Atoms, Institutions, and Blockchains. So I highly encourage people to try to read that. But the basic idea is that our society benefits from a lot of these different functions, things like money, voting, property ownership, identity, like things that can be expressed as systems of rules, and where it's very important for those things to be secure. Those things do not have to be efficient, right? And it's okay for those things to be inefficient, but they have to be secure. They have to not break. They have to be, you have to be able to trust that those things will be there for you when you absolutely need them, right? We have to trust that these things will not be corrupted, that whoever is managing them will not change them arbitrarily. And these kinds of properties, they're very difficult to get. And they're more difficult to get once these social institutions start to become digital, right? When something is physical, it's still easy to understand how something works. It's easy to do inspections. It's easy to check lots of things. On the internet, when everything is going through a small number of servers, this becomes more difficult. And so what blockchains are a great tool for letting us do is creating these kinds of social institutions that have hardness, that have these security properties, so you can understand what is going on, you can see what the rules are, and you can be sure that the rules tomorrow or the rules 1 year from now will be the same as the rules today, but on the internet, right? So depending on what kinds of things you care about, there are different ways of thinking about what kinds of goals Ethereum is trying to achieve. And I think all of these perspectives are valid, right? I think there are different angles that can appeal to different people depending on which side of all of these things that you care the most about. Now, what is Ethereum in a technical sense, right? So it is a blockchain. So what is a blockchain? A blockchain is a data structure that lives in this kind of decentralized computer network that consists of everyone running an Ethereum node, right? So if you've downloaded Geth or Prism or Nimbus or any of these nodes, who here has downloaded and synced an Ethereum node? So if you have, you're part of the Ethereum network. And in this network, there lives this data structure called a blockchain, where what you have is you have a series of blocks. And each block contains transactions. And each block contains a link to the previous block, right? So there is a chain, and if you have one of these blocks, then you can go backwards through the chain, and you can download all of these previous blocks as well. The blockchain keeps track of this data called the state, and inside of the state is things like accounts, right? So if you, as a user, have coins on Ethereum, could be ETH, could be ERC20 tokens, could be NFTs, then those coins are part of the state. And the state gets updated over time, and it gets updated over time as a result of processing these transactions that people submit. So, what are transactions? A transaction on Ethereum is a digital message that has a digital signature attached. The digital message is an instruction that contains things that you want to do. So, for example, if you have 10 ETH and you want to send 1 ETH to your friend, then the request to send 1 ETH from your address to your friend's address would be data that gets packaged and encoded into a transaction. The transaction has a digital signature. A digital signature is basically a cryptographic algorithm that allows you to make a proof that that transaction actually came from you and actually was authorized by you. So how do we define you, right? Blockchains are what's called pseudonymous, right? So to have an account at a blockchain, you do not have to provide your passport, you do not have to provide a phone number, you do not have to get your face scanned anywhere. All you need to do is run an algorithm locally on your computer to generate a set of 2 keys. One of those keys is called a private key, one of them is called a public key. There's a mathematical formula that can just generate as many pairs of private and public keys as you want, and anyone can go do this right now, right? Now, the private key is a key that you can use to sign messages. So there is another mathematical formula that you can use, where if you use your private key and you take a message, it generates a signature for that message. And then there is another formula for verifying signatures, right? So if you have someone's public key, and you have that same message, you can verify that key actually signed the message. So private key, you keep it secret, don't tell other people, it's for signing. Public key, tell everyone else, it's for verifying. So a user sends transactions, sign them with their private key, and these transactions contain instructions about things that they want to do. These transactions get included into these objects that are called blocks. And those transactions, when they get included into a block, they come in some order. So in a block, there is the first transaction, second transaction, third transaction, and so on. On average, an Ethereum block has something like 200 transactions, I believe. And then the blocks form a chain, and so the blocks also have an order. Now, if you process all of those transactions in order, then you can recompute the current state. And the current state contains things like how many coins that you have, like what kinds of applications have been published for each application, what kind of information has it decided to save. So an account in a chain is an object that can represent either a user or an application. Right? So people might have heard of externally owned wallets. These are wallets that are directly controlled by a particular private key. Now with account abstraction, which is one of these very new things that is being developed, actually the other type of account, which is a smart contract, which is an account controlled by a piece of code, can also represent a user, right? So an account that uses what's called a smart contract is an account that is controlled by a piece of code. And you can send a message into that account, and then the code of that account runs, and that account does things. So you can think of an account as being like a tiny little robot that exists on the blockchain that follows a precise set of rules that you specify when you create that contract. And so any one of these accounts, they can represent either a user, so you can have one of these little robots that represents you on Ethereum, or it can be an application, right? So for example, a token, right? So who here has USDC? So if you have USDC, there's one USDC contract, which is one of these accounts that is on the Ethereum chain, and it has a piece of code. That piece of code has rules that say, if you are, if you send a message to this account, it will check if you have, what is your balance. If you want to send points to someone else, if you have enough balance, it subtracts your balance by that amount, and it increases the other person's balance by that same amount. Right, so you take that logic, those rules that make up a coin, and it's that a piece of code representing that logic is the code of the accounts that represents the entire USDC system on Ethereum. And then if you hold USDC, then you basically, what you have is you have a storage entry, like the little number 27 over here, inside of one of these accounts. So accounts can have code. When an account receives a message, the code executes. The code execution can read or write to the contract's internal storage, right? So every one of these accounts has its own sort of virtual main hard drive inside of a virtual big hard drive. And you can read and write, and you can also an account can also send messages to other accounts, right? So these accounts that are on Ethereum can talk to each other. All of this talking between accounts is always initiated by a transaction. Right, so a transaction is like a top-level message that just starts by sending a message into one account, and then that account has code, and then that account starts doing things. Consensus. So one really important thing about Ethereum is that Ethereum is a decentralized platform. There is no central operator that runs the system. One of the tasks that is very easy to do in a centralized way, but very hard to do in a decentralized way, is agreeing on which transactions or and which blocks to include in which order. So the way that Ethereum works is time is broken up into what are called slots. You have one slot every 12 seconds, and during every slot, you have a random node, actually a random staking node, called a validator that gets chosen. The validator has the right to create a block, and in that block, they can include all of the transactions that they know about that have not been included already. Now, there's a problem here. What happens if you have one of these validators that gets chosen? They are malicious. And what they do is they create two different blocks that both point back to the same block, but those two blocks are not compatible with each other, right? So for example, let's say I have 10 ETH, and I want to send 7 ETH to you, and I want to send 7 ETH to someone else. I could create two blocks, and in the first block, I put the first transaction, and I show it to you. In the second block, I put the second transaction, and I show it to the other person, right? So you think that you got 7 ETH from me. The other person also thinks that they got 7 ETH from you, but I only have 10 ETH, right? So if this attack was possible, it would allow anyone to just hyperinflate any of these, like any currency or any application that is on Ethereum. And so in the case where there are two blocks like this that conflict with each other, we have this consensus process. What happens here is you have a much larger set of validators. Actually, in each slot, about 3% of all of the stakers in Ethereum that get sent a message called an attestation. And an attestation is basically a vote. It basically says, did you see this block first, or did you see the other block first? And so you have a vote. Usually one block wins. If it's close to a 50-50, then there is a mechanism called a consensus algorithm that chooses which one of these blocks wins. And so the chain keeps on growing, right? So you have a block, and then you have many attestations. You have a block, and you have many attestations. Now, to be producing one of these blocks or one of these attestations, you have to not just be an Ethereum node, you have to be a staking node, right? So staking basically means when you deposit 32 ETH, 32 units of Ether, the internal currency of Ethereum, then you can put 32 ETH into a special system where you then become a staker. And when you become a staker, you have the right to sometimes create blocks, sometimes create accusations. If you do something that is invalid, so like for example, if you create 2 blocks when you should have created 1 block, then you get penalized. Like part of the 32 ETH that you deposited might be destroyed by the system. If you do not, then you get rewarded, right? You get rewarded by rewards from the protocol and by transaction fees from transactions that users send. So this entire thing is basically the system that's designed to just constantly agree on new blocks, keep on adding new blocks to the chain, and do it in such a way that the mechanism itself is open for people to participate, right? So if you have 32 ETH, you can become a staker. If you have less than 32 ETH, then you and other people can join something which is called a staking pool. And so as a group, when you get to 32 ETH, then you can become one staker and you can participate in the system as a group. Right, so there's a lot of these staking pools that are being created, a lot of work even creating decentralized staking pools. So there's different ways to stake here, right? You can either stake by yourself, as I'm doing, or if you have less than 32 ETH, then you also have many options for joining a decentralized staking pool. So staking is the way that you, as a user, can actually participate in creating in these blocks and helping the network to agree on the order in which these blocks are coming in and ensure that the chain continues stably growing with one new block every 12 seconds. Layer 1 versus Layer 2. This is one more of these big changes that has happened to Ethereum over the past 3 years. So before a couple of years ago, Ethereum was just a Layer 1. So you have Ethereum, and then if you want to do something on Ethereum, you would just send transactions to Ethereum, and they would run on Ethereum. More recently, we have Layer 2s. So Layer 2s are like separate blockchains that are still linked into the Ethereum Layer 1. Right, so over here we have this Layer 2 chain, and you have Layer 2 blocks, and Layer 2 blocks also form a chain. They point to each other, but the hash of each Layer 2 block gets included into the Ethereum Layer 1. Most computation and data in a Layer 2 is done outside of Ethereum. And because it's done outside of Ethereum, it can be much cheaper. It's much cheaper because for something done inside of Ethereum, every single person who runs an Ethereum node would need to download and check it. So you'd have tens of thousands of people that would need to all download and check that data, and so it would be very expensive. But with a Layer 2, most computation and most data is done outside of Ethereum. However, Layer 2s still benefit from Ethereum security. And so what you have in a Layer 2 is you have a mechanism where there is some set of kind of proof system where if you have something in a Layer 2, then the Layer 1 can actually prove that you do actually have the asset in the Layer 2. And so it ensures that you actually can withdraw it from the Layer 2 to the Layer 1. And your assets cannot be stolen, even if something inside of the Layer 2 goes wrong. There are many different kinds of Layer 2s, so you might have heard of rollups, optimistic rollups, ZK rollups, plasma, validiums, many different kinds of systems, but this is what Layer 2s are in general. They are networks that are outside of Ethereum. You can interact with them, you can publish transactions, you can read, you can write, you can build applications in the same way that you can with Ethereum. But these networks still benefit from